Welcome to the DIY Honda Garage channel. The DTC B1279 pertains to a malfunction in the dimmer switch circuit of the Honda CRV models from 2017 to 2022. This diagnostic trouble code indicates that there is a malfunction within the circuit associated with the dimmer switch, which is integrated into the body control module, BCM. The BCM plays a critical role in controlling various electrical components in the vehicle, including the lighting system. When this code is triggered, it signals that the BCM has detected an issue related to the dimmer switch operation, often requiring further investigation to diagnose the specific cause. It's essential to note this code may manifest alongside symptoms that affect other components, compelling technicians to perform a systematic diagnostic approach to isolate and rectify the issue effectively. Understanding the dimmer switch's functionality, its wiring connections, and relationship with the BCM is crucial to addressing this code. The DTC B1279 specifies a malfunction in the dimmer switch circuit, specifically focusing on the electrical pathways and signals pertaining to the dimming of the vehicle's lights. The dimmer switch itself is a crucial component that adjusts the brightness of the interior and exterior lights, controlled by the body control module, BCM. The BCM, typically located in the vehicle's dashboard or behind the engine compartment, regulates electrical processes within the car, ensuring that commands from the driver result in the appropriate responses from the vehicle's lighting and other systems. A problem in this circuit can affect functionalities such as headlights and dashboard lights, leading to poor visibility and potential safety hazards. Identifying the root cause of this malfunction involves examining the connections and wiring associated with the dimmer switch, as well as the BCM's functionalities governing these systems. Several possible causes may lead to the activation of DTC B1279. The most common culprit is a faulty combination light switch, which controls various lighting functions, including high beams and passing lights. If this switch malfunctions, it can disrupt the signals sent to the body control module, resulting in erroneous output. Another important consideration is shorted wiring connections that could compromise electrical integrity, leading to intermittent signals or complete circuit failure. This could mean damaged insulation or poor connections that cause shorts between wires. Lastly, a malfunction of the body control module itself can also trigger this code, indicating that the component responsible for processing light switch inputs may require repair or replacement. Each of these components must be thoroughly checked during diagnostics to determine the exact cause. When experiencing DTC B1279, several symptoms may become apparent, which reflect the malfunction of the dimmer switch circuit. One of the most obvious symptoms is the inoperative headlights, which can pose significant safety hazards, especially during night driving conditions. Additionally, drivers may observe inconsistent dimming functionalities, where lights do not respond adequately to dimming adjustments or remain at an undesired brightness. This could lead to an uncomfortable driving experience or unnecessary strain on the eyes. Another related symptom may involve dashboard light failures, where the instrument panel fails to illuminate correctly, adversely affecting visibility of critical driving information. Recognizing these symptoms is vital, as they directly impact driving safety and vehicle functionality, prompting timely troubleshooting and repairs. The first step in troubleshooting DTC B1279 is to perform a diagnostic check of the headlight switch parameters. Begin by placing the headlight dimmer switch in the neutral position. Using the HDS or Honda Diagnostic System, check the parameters of the headlight switch, particularly observing the signals from the high beam and passing switches. This step is essential as it determines whether the switch is communicating correctly with the BCM. If either information indicator is illuminated, This suggests a fault in the circuit, leading us to proceed to the next troubleshooting step. However, if no indicators are on, it suggests a potentially intermittent failure in the system at this time, implying the need for further investigation without any immediate repairs. Next, position the headlight dimmer switch to the high beam setting for the second diagnostic check. Again, use the HDS to review parameters regarding the headlight switch signals. At this point, the focus is on ensuring both the high beam and passing information indicators are illuminated. If both indicators are indeed on, this reinforces a potential fault condition within the wiring or switches, since they are intended to signal different light functionalities. In contrast, if the indicators are not illuminated, this suggests an intermittent failure that may not warrant immediate repairs, though continued monitoring of the situation may be needed. An understanding of the operation of both switches here is critical for effective troubleshooting. Proceeding to the third diagnostic step, a focus will shift to checking for short circuits within the wiring. First, ensure that the vehicle is in the off lock mode before disconnecting the combination light switch's 12P connector. Subsequently, connect terminals A and B with a jumper wire to create a direct pathway for electrical testing. Specifically, you will link terminal A from the body control module connector C 28P number 8 with body ground. By utilizing the HDS once again, you'll evaluate the parameters of the high beam and passing switch signals. Should both indicators light up at this point, it indicates a short in the wiring that will need repair. Conversely, if no indicators activate, this suggests that the wiring integrity is intact, shifting the focus towards potential replacement of the combination light switch after this check. In this fourth step, you will again investigate the potential failure areas within the circuit. Begin by ensuring the vehicle remains in the off lock position prior to disconnecting the combination light switch's 12P connector. Following this disconnection, immediately check the headlight switch parameters using the HDS diagnostic tool once more, focusing on the signals from the high beam and passing switches. If the indicators remain illuminated at this stage, the issue might lie deeper, necessitating further analysis. If both indicators are off, however, it strongly suggests the need for replacing the combination light switch, as it is not providing the necessary signals to the BCM, which ultimately controls the effective operation of the vehicle's lighting system. Each of these checks is essential in pinpointing the exact linkage of cause and effect within the lighting circuit. The final step involves checking for continuity in the wiring associated with the passing and high beam switches. Once the vehicle is in the off-lock mode, ensure both the combination light switch and body control module connectors are disconnected before proceeding. At this point, it is essential to assess continuity between defined test points, specifically body control module connector C 28P number 7 and body ground, as well as connector C 28P number 8 and body ground. If continuity is confirmed, it indicates a short to ground situation within the wire, requiring repairs to restore expected system functionalities. If there is no continuity, it suggests that the passing SW and HL high SW wires are functioning correctly, which would typically lead to replacing the body control module if all other components are validated as operational. After all necessary repairs and part replacements are completed to address the DTC B1279, it's pivotal to perform a final verification of the system's integrity. Begin by powering on the vehicle and utilizing the HDS once again to test the lighting system and all associated parameters. This ensures indicators function correctly, confirming that all repairs have effectively resolved the reported issues. Particular attention should be given to testing all light functionalities, especially the dimmer switch effects, to ensure they operate in accordance with driver commands. Comprehensive documentation of all findings throughout the troubleshooting steps, parts replaced, and tests completed should be meticulously recorded. Not only does this fulfill professional standards, but it also provides a clear history for future diagnostics if similar issues arise. To prevent potential future occurrences of DTC B1279 related to dimmer switch circuit malfunctions, maintaining a strict preventive maintenance schedule is advisable. Regularly checking the vehicle's lighting systems can help identify issues before they escalate into full-fledged failures. This includes routine inspections of wiring insulation for any signs of wear or damage, which can lead to shorts and malfunctions. Additionally, ensuring that the body control module and related systems are updated with the latest software patches can help maintain optimal performance and responsiveness of vehicle controls. It's also beneficial to perform visual checks around the combination light switch and associated connectors to ensure that connections remain secure and unaffected by external elements. Such proactive measures not only enhance the operational reliability of the vehicle, but also contribute to overall driving safety. In conclusion, recognizing and properly addressing DTC B1279, which points to a dimmer switch circuit malfunction, is essential for ensuring the optimal performance of the Honda CRV lighting systems. A systematic approach to troubleshooting allows technicians to identify and rectify issues effectively, improving reliability and safety for the driver and passengers. Through understanding the interplay between the dimmer switch, body control module, and the associated wiring, one can ensure a thorough diagnosis free from guesswork. Incorporating preventive maintenance into regular vehicle care will extend the lifespan of related components, while reducing the likelihood of similar codes emerging in the future. Keeping all service documentation organized and up to date will aid in swift diagnosis during any subsequent issues, ultimately fostering a safer driving experience. Please like and subscribe to the channel. See you next time.